Hello everyone. Today we are going to see what is the solution of UT question paper. Question number 1a, solve d square y by dx square minus 2 dy by dx is equal to e raised to x sin x. This is a linear differential equation with a constant coefficient. Right hand side is non-zero, so this is non-homogeneous. So solution of this differential equation will be y is equal to yc plus yp. Okay, so yc, for yc we have to find auxiliary equation. Auxiliary equation is d square minus 2d is equal to 0. Since this equation can be written as d square y minus 2 dy is equal to e raised to x sin x. So taking y in common we obtain its auxiliary equation. So d into d minus 2 is equal to 0, which implies that d is equal to 0 comma 2. Okay, so these are the roots of the auxiliary equation. Okay, now yc is equal to, what is yc? Independent variable is x, so yc is c1 e raised to first root multiplied by x plus c2 e raised to second root multiplied by x. Roots are real and distinct. Okay, to find yp, that is particular integral, we have to use shortcut case 5. Why shortcut case 5? Because you have e raised to x into sin x. So this is what exponential into some function of x. This is the case 5 of shortcut method. Okay. So yp is equal to 1 upon 5 of d, that is 1 upon d square minus 2d operating on e raised to x sin x. What is case 5? It is yp is equal to 1 upon 5 of d e raised to ax into v can be written as e raised to ax 1 upon 5 of d plus a operating on v. So what this shortcut case says, you have to take exponential outside the inverse differential operator, and at the same time simultaneously you have to change this d, replace this d by d plus a, d plus coefficient of x in exponential. Okay, so here coefficient of x in exponential is 1, so yp can be written as 1 upon, e raised to x times exponential we have to take outside the inverse differential operator, so e raised to x into 1 upon d plus 1 bracket square minus 2 times d plus 1 sin x. So yp is equal to e raised to x into 1 upon d square plus 2d plus 1 minus 2d minus 2 sin x. So yp is equal to e raised to x 1 upon, this is d square plus 2d minus 2d plus 1 minus 2, so finally it is minus 1 operating on sin x. Now this is the case of sin ax plus b. Okay, if you have sin ax plus b on right hand side, then we replace d square by minus 1. Okay, so here you have to replace d square by minus 1, so yp is equal to e raised to x 1 by minus 1 sin x. So final yp is equal to minus e raised to x sin x divided by 2. This is your answer. Okay, now question number 2 in, so this is the problem of method of variation of parameters. This method is compulsory, you have to solve in INSEM. Okay, compulsory one question will be there, two questions will be there on method of variation of parameters. Okay, so here we have to find yc first. Okay, rewrite the differential equation in terms of capital D. So it is d square plus 1 operating on y is equal to sec x tan x. So auxiliary equation is d square plus 1 is equal to 0. So roots of the auxiliary equation d square is equal to minus 1. So d is equal to under root minus 1, that is plus minus iota. Okay. So yc is equal to, if roots are complex, roots are imaginary, then yc is equal to e raised to a real part. In this case real part is 0, so real part into x into another bracket c1 cos of imaginary part is 1, coefficient of I it is 1, so cos of x plus c2 sin of x, that is yc is equal to e raised to 0x is 1, so c1 cos of x plus c2 sin of x, this is your yc. Now in case of method of variation of parameters, you have to choose y1 and y2 from yc. Okay, yc has two terms. Okay, and for the two terms you have two different functions of x. Okay, so y1 is equal to cos of x, first part of the yc, and y2 is equal to sin of x, it is second part of the yc. Okay, so cos x sin x are two functions you have. Now for these two functions, yp of this differential equation is equal to u times y1 plus v times y2, where u is equal to integration minus y2 f of x divided by Wronskian dx, and v is equal to integration y1 f of x Wronskian dx. U is equal to what? Wronskian is equal to what? Wronskian is equal to determinant of y1 y2 y1 dash y2 dash, y1 dash y2 dash are derivatives of y1 y2. Okay, so it is equal to y1 is equal to cos x, y2 is equal to sin x, derivative of cos x, y1 dash is derivative of y1, cos x डेरिवेटिव cos x का डेरिवेटिव क्या होता है माइनस साइन एक्स, और साइन एक्स का डेरिवेटिव cos x. So this determinant w is equal to Wronskian is equal to cos into cos will be cos square x minus sin x into sin x, so minus sin square x. So it is clearly equal to cos square x plus sin square x. So Wronskian is equal to 1. By using basic identity of trigonometry, cos square x plus sin square x is equal to 1. So Wronskian is 1. So u is equal to integration, use y2 f of x and Wronskian in this formula. y2 is equal to sin x, so minus sin x multiplied by f of x is right hand side function, it is sec x into tan x, divided by Wronskian is 1 dx. Okay, so put out all the values of corresponding functions. So u is equal to integration minus sin square x divided by cos square x dx. Why? Because you have sin x in the numerator, tan x in the numerator. So tan x is equal to sin x by cos x, and sec x is equal to 1 by cos x. So you have product of all numerators, and it is sin into sin, sin square. Product of all the denominators, cos into cos, cos square. So denominator is cos square x. So u is equal to, again use the same identity. Sin square x can be written as 1 minus cos square x. Okay, so minus 1 minus cos square x divided by cos square x dx. So u is equal to multiply by 1 inside, multiply by minus 1 inside. Okay, so it is cos square x minus 1 divided by cos square x dx. So u is equal to integration, divide this cos square x separately to these two terms. So cos square x by cos square x will be 1 minus 1 by cos square x will be sec square x dx. So u is equal to, now these are the perfect derivatives. Okay, complete derivatives we have. So derivative of x is equal to 1, so integration of 1 is x minus integration of sec square x, it is sec square x किसका डेरिवेटिव है tan का, Okay, so it is tan x. So u is equal to x minus tan x. Now v is equal to integration y1 f of x divided by Wronskian dx. So it is equal to y1 is cos x into f of x is sec x tan x divided by Wronskian is 1 dx. So v is equal to integration cos will be cancelled, okay, because cos and sec are reciprocals of each other. So multiplication of cos and sec is 1. So simply tan x dx. So what is, hence v is equal to integration tan x dx is equal to log of sec x, okay, hence yp is equal to u times y1 plus v times y2, that is x minus tan x times cos x plus log of sec x into sin x. So what is your complete solution? Complete solution is yc plus yp. Y is equal to yc plus yp. Write yc and yp together. That will be your required solution. Okay. Nth order derivatives. Okay. So in this case we are going to use basic substitution, and the substitution is you have to take 2x plus 1 is equal to e raised to z. This is the basic substitution. Okay, so accordingly we have to find values of x and z. So z will be equal to e raised to z is equal to this, so z is equal to, taking log on both sides, it is log of 2x plus 1. Okay, similarly you can find x by using this equation. So x is equal to, take this e raised to z minus 1 shift this 1 to right hand side divided by 2. This is your x. Okay, and basic substitutions for 2x plus 1 bracket square d square y by dx square is 2x plus 1 bracket square d square y by dx square is equal to 2 square d into d minus 1 operating on y. What is this 2? This 2 is coefficient of x in ax plus b. Okay, so in case of general formula you have a square multiplied to this operator d into d minus 1. What is d here? D is equivalent with dy dz. Now the independent variable is changed from x to z. Okay, now x is not your independent variable. Independent variable for this capital D is z. Okay, this is what you have to keep in mind, okay, while solving the problem. Now for 2x plus 1 dy by dx, it is equal to 2 times dy. Okay, order of the differential equation, order of the differential coefficient is 1, so we have 2 raised to 1. If nth order differential coefficient you have, then you will have 2 raised to n here. Okay, so use all these substitutions in the problem. So given dE reduced to is reduced to 2x plus 1 bracket square d square y by dx square is equal to 2 square d into d minus 1 y minus 6 times 2x plus 1 dy by dx is 2 times dy plus 16y will be as it is. Okay, 16y will be as it is equal to 8. 2x plus 1 is equal to e raised to z. So e raised to z bracket square. So 4d into d minus 1 y. Now this is the differential equation in y and z. Okay, x is replaced by z, so independent variable is z now. Minus 12 dy plus 16y is equal to 8 e raised to z bracket square, so it is e raised to 2z simply. So 4d square minus 4d minus 12d plus 16 operating on y. Take y in common from each of the term. Okay, So 8 e raised to 2z. 4d square minus 12 minus 4 minus 16 d plus 16 y is equal to 8 e raised to 2z. Now throughout the equation you can observe 4 is common multiple of every term. So you can divide the equation by 4. So you will have d square minus 4d plus 4 times y is equal to 2 e raised to 2z. This is the differential equation in y and z. Okay. So let this be equation, let this be star. Okay. So yc is equal to, sorry, firstly you have to find auxiliary equation. Auxiliary equation is d square minus 4d plus 4 is equal to 0. So this is perfect square of d minus 2. Okay, that is d is equal to 2 comma 2. So this is a real repeated case of real repeated roots. So yc is equal to c1 plus c2 z e raised to 2z. Why z? Because z is independent. Okay, and we take independent variable in the yc. So c2z e raised to 2z. Now yp is, for yp you have to apply shortcut case. Okay, yp is equal to 1 upon d square minus 4d plus 4 operating on 2 e raised to 2z. 2 is constant, so you can take it in common. Okay, so 1 upon d square minus 4d plus 4 operating on e raised to 2z. So this is the case of exponential in shortcut. First case, if you have e raised to ax, then we replace d by a in the denominator. Here you have e raised to 2z. So shortcut case will now shortcut case will be applied as z is independent. So coefficient of z is 2. So d is replaced by 2. So 2 times 1 upon 2 square minus 4 times 2 plus 4 into e raised to 2z. But what about the denominator? Already you know that this is perfect square of d minus 2. Okay, that is 2 is root of the denominator. That means here we have case of failure. Denominator will be 0 after replacing d by 2. Okay, so this is case of failure. Now you have d square minus 4d plus 4 is equal to d minus 2 bracket square. So you will have case of failure 2 times. Okay, that means 2 times z by 2d minus 4 operating on e raised to 2z. Again this is 2d minus 4. After replacing d by 2, again you will have case of failure. So it is equal to 2 times z square, increase the power of z and take the derivative of denominator. It will be 2 e raised to 2z. So yp is equal to z square e raised to 2z. Yp is equal to z square. Why we are taking z square? Because again replacing d by 2 will give you 0 in the denominator. Okay, so yp is equal to this. Now you have yp and yc in terms of z. So y is equal to c1 plus c2z e raised to 2z plus z square e raised to 2z. Both the things are in z, but actual differential equation has x as your variable, so you have to resubstitute for z. What is z? Z is equal to log of 2x plus 1 and e raised to z is equal to 2x plus 1. So make this change in the solution. So it is c1 plus c2. Z is log of 2x plus 1. Outside the bracket e raised to 2z can be written as 2x plus 1 bracket square, because e raised to z is 2x plus 1 and you have square of e raised to z. So it is square of 2x plus 1 plus z square is log of 2x plus 1 bracket square multiplied by e raised to 2z is again it is 2x plus 1 bracket square. So this is your final answer in terms of x. 99% बच्चों ने इसमें मिस्टेक की है. ओके, आपको ये ध्यान में रखना है कि आपने वेरिएबल चेंज किया है. x जो था आपका इंडिपेंडेंट वो अभी चेंज हुआ है और अभी आपका इंडिपेंडेंट z है. ओके, आफ्टर यूजिंग सब्सटीट्यूशन. ये आपको ध्यान में रखना है while solving the problem. So this is the example of simultaneous linear differential equations. You have to rewrite these equations by using capital D. For capital D, sorry, small d by dt, we are going to use capital D. So equation 1 will be dx plus 5x minus 2y is equal to t. That is d plus 5x minus 2y is equal to t. This is your equation 1. Equation 2 is dy plus 2x plus y is equal to 0. Now we are going to use Cramer's rule to solve this example. So in such type of examples you have to maintain the order, take x first and then take y. So you have to rewrite this equation in the order. So take this 2x first, okay, plus d plus 1 operating on y is equal to 0. So this is your second equation. Now coefficients of x are d plus 5 and 2. Now coefficients are in order. Okay, so by using Cramer's rule, del is equal to determinant of coefficients only. So how many coefficients you have? Total 4 coefficients. Write down first column as coefficients of x. So d plus 5, 2. Second column of del is coefficients of y. So minus 2, d plus 1. So it is equal to, it will give you auxiliary equation. Okay, auxiliary polynomial it will give you. So del is equal to d plus 5 into d plus 1 minus 2 times minus 2. So del is equal to d square. Now product of two linear factors is equal to square of the first term, which is common in both the brackets, plus addition of both the constants. 5 plus 1 will be 6, so 6d, plus product of both the constants, so it is 5, minus this is 2 into minus 2, so plus 4. So del is equal to d square plus 6d plus 9. This is your auxiliary polynomial. Okay, so auxiliary equation is d square plus 6d plus 9 is equal to 0, which implies that d plus 3 bracket square is equal to 0, because this is perfect square expansion of d plus 3. So d is equal to minus 3 comma minus 3. So this is case of real repeated roots. Hence yc is equal to, what is yc? Yc is equal to, keep in mind in case of simultaneous examples you have t as independent variable. So c1 is equal to, sorry, yc is equal to c1 plus c2 t e raised to minus 3t. X is not independent. In this case x is also dependent variable, y is also dependent, and both depends on t. So c1 plus c2 t e raised to minus 3t. This is your yc. To find yp, we are going to take del y. Okay, del y is determinant of, in this del you have to change the second column as you are finding del y. So change the column corresponding to y, change the coefficients of y by right hand side. Okay, coefficients of x will be as it is, d plus 5 2, right hand side in this case is t0. Okay, so right hand side is t0. So d plus 5 operating on 0, sorry, multiplied by 0 minus something is wrong here. Wait, no, it is right. Okay, so minus 2t. So del y is equal to minus 2t. Now what is your del? Del is equal to d square plus 6d plus 9. So in general, yp is equal to del y by del, that is minus 2t by d square plus 6d plus 9. So this is similar to inverse differential operator operating on function. So it can be written as 1 upon d square plus 6d plus 9 operating on minus 2t. So you have to use basic polynomial case of shortcut to find the answer. Okay. So what we do, we use formula of 1 by 1 plus x or 1 by 1 minus x to solve such type of polynomial functions yp. Okay. So rewrite this d square plus 6d plus 9 as 1 plus some function of d. So in such examples, we take constant term in common. So here constant term is 9. So take this 9 in common. Okay. So yp can be written as 1 upon 9 into bracket d square plus 6d by 9 plus 1 operating on minus 2t. Okay. So yp is equal to 1 by 9 1 by 1 plus d square plus 6d by 9 operating on minus 2t. Now for the formula 1 by 1 plus x, we know that it is equal to 1 minus x plus x square minus x cube plus dot dot dot. Okay, this is the formula we are going to use. Now replace x by this d square plus 6d by 9 in this formula. You will get required expansion. So yp is equal to 1 by 9. 1 minus x is d square plus 6d by 9. Okay, plus all further derivatives. Now you have minus 2t as your polynomial, and this is linear polynomial, so its first derivative is non-zero, but second derivative and all onwards derivatives are 0. Okay, so you don't have to take all these further terms x square x cube, because in case of x square you will have square of this term, and square of this term will contain fourth derivative, third derivative and second derivative, which of them, so all of them are 0. Okay, so you don't have to consider the square and onwards powers of this bracket. Okay, so close the bracket right over here operating on minus 2t. So yp is equal to 1 by 9, 1 into minus 2t minus second order derivative is 0 minus 6 by 9 d of this minus 2t, it is minus 2, close the bracket. So yp is equal to 1 by 9 into bracket minus 2t plus 12 by 9. 12 by 9 is 12 by 9 is 4 by 3. So 1 by 9 minus 2t plus 4 by 3. So again you can simplify it, multiply by that 1 by 9 inside. So it is minus 2 by 9 t plus 4 by 27. That is your final yp. Now you have yc plus yp. Yc is equal to c1 plus c2 e raised to c2t e raised to minus 3t plus yp is equal to 4 by 27 minus 2 by 9t. Now y you have in your hand, you have to find x by using y in any of the equations. Okay, so you have two equations. From that two equations you have to select the equation where derivatives of x are not involved. Why? Because you don't have x in your hand to differentiate it. Okay, you have only y. So choose the differential equation where you have derivatives of y. Okay, so this is the second equation. You have 2x plus d plus 1y is equal to 0. By using this, find out the value of x. It is equal to x is equal to minus d plus 1 y divided by 2. Okay, so now you have y, so x is equal to minus d plus 1 y is c1 plus c2t e raised to minus 3t plus 4 by 27 minus 2 by 9t divided by 2. Okay, divided by 2. Keep this minus 1 by 2 constant as it is and take the derivative of inside function. So this is d of c1 plus c2t e raised to minus 3t plus 4 by 27 minus 2 by 9t plus the function as it is c1 plus c2t e raised to minus 3t plus 4 by 27 minus 2 by 9t over. So x is equal to minus 1 by 2 is constant. Derivative of this function, this is product of two functions. Okay, so we have to use product rule to differentiate. Keep this c1 plus c2t as it is. Derivative of e raised to minus 3t, it is minus 3 e raised to minus 3t plus keep e raised to minus 3t as it is. Derivative of c1 plus c2t is c2 simply. Okay, plus derivative of 4 by 27, it is 0, plus derivative of minus 2 by 9t, it is minus 2 by 9 plus c1 plus c2t e raised to minus 3t plus 4 by 27 minus 2 by 9t. Okay, so x is equal to, collect all like terms together. So e raised to minus 3t is exponential you have, so take exponential common from all of the terms. So e raised to minus 3t into bracket, multiply this minus 3 inside, so minus 3c1 minus 3c2, this is c2 and this is plus c1 plus c2t. Okay, oh sorry, now you have minus 3c1 minus 3c2t here. Okay, minus 2 by 9 plus 4 by 27. Do rough calculations. Minus 2 by 9 plus 4 by 27 will be, make the denominator same after multiplying this first ratio by 3. Okay, numerator and denominator by 3. So 4 minus 6 by 27, it is equal to minus 2 by 27. So minus 2 by 27 minus 2 by 9 t. Okay, close the bracket here because you have exponential multiplied to this terms only. Okay, now what you can do, you can take this minus 3 to t in common. Okay, and constant separate, so you can have minus 3c2 plus c2. Okay, so it is minus 2c2 minus 3c1 plus c1 will be minus 2c1. So x is equal to minus 1 by 2 e raised to minus 3t minus 3c1 plus c1 minus 2c1 minus 3c2 plus c2 minus 3c2 plus c2 minus 2c2t. Okay, minus 2 by 27 minus 2 by 9 t. This is your final answer. Okay, so now in case of simultaneous differential equations, you have to use Cramer's rule. It will give you answer in less number of steps. Okay, instead of by using direct elimination, you can use Cramer's rule. So this is the differential equation where we have to use shortcut case again for cos of ax plus b and for exponential one. This is 2 raised to x. 2 raised to x can be written as 2 raised to x is equal to e raised to log of 2 raised to x. Why? Because exponential and log are inverses of each other. So you can rewrite it as e raised to log of 2 raised to x. That is 2 raised to x can be written as exponential of x times log 2. Okay, so this function can be converted as exponential of something. So again shortcut case for exponential function will be applied. here. Okay, so rewrite this differential equation by using capital D. So it is dq plus dy is equal to cos of x plus 2 raised to x. So auxiliary equation is dq plus d is equal to 0, which implies that d into bracket d square plus 1 is equal to 0. Hence roots are d is equal to 0 or plus minus I. Okay. Hence yc is equal to, now as you have three roots, okay, you will have three arbitrary constants in yc. Okay, that is c1, one root is real, so for that real root c1 e raised to 0x plus c2 cos of x plus c3 sin of x. Since a real part of this complex root is 0, so you don't have exponential term in that solution. So yc is equal to c1 plus c2 cos 2x, cos x plus c3 sin x. This is your yc. Now to find yp, separate that inverse differential operator 1 upon dq plus d on both of the functions cos x and 2 raised to x. So it is equal to 1 upon dq plus d operating on cos x plus 1 upon dq plus d operating on 2 raised to x. So it is for the first part you have to apply case of cos of ax plus b. So here you don't have what we can say even degree terms here. Okay, we have to replace d square by minus 1 here. So for this you have to take this d in common, d square plus 1 cos of x plus 1 upon, replace d in case of a raised to x, you have to replace d by log a everywhere. So here we are going to replace this d by log 2 multiplied by 2 raised to x. Okay, don't forget to write this 2 raised to x. This is the function and it will remain as it is after finding yp. Okay, plus 1 upon this 1 upon d is integration. 1 upon d works as integration, so take integration of cos of x plus 1 upon log 2 bracket cube log 2 operating on 2 raised to x. So it is equal to derivative of cos x is sin x, so 1 upon d square plus 1 sin x. This will be the same solution. Okay, so 1 upon d square plus 1 sin x. Again you have sin ax plus b, so replace d square by minus a square, replace d square by minus 1. So you will have denominator 0 after replacing d square by minus 1, because minus 1 plus 1 is 0. So this is case of failure. So in case of failure you have to take x in the numerator and take the derivative of denominator. It is 2d sin x. Okay, again 1 upon d is simple integration. 1 upon d works as integration, so 1 upon d sin x is integration sin x dx. Second half of the solution will be as it is. So yp is equal to x by 2, integration of sin is minus cos x, okay, plus 1 upon log 2 cube plus log 2 2 raised to x. So yp is equal to minus x cos x by 2 plus 1 upon log 2 2 raised to x. So final complete solution is y is equal to yc plus yp, that is equal to c1 plus c2 cos x plus c3 sin x, plus yp is equal to um, okay, so you have minus x cos x divided by 2 plus 1 by log 2 bracket cube plus log 2 operating on 2 raised to x. So next problem is solve by method of variation of parameters. D square minus 2d plus 2 y is equal to e raised to x tan x. Again, in case of method of variation of parameters, we need u, v and Wronskian. Okay, so for Wronskian we have to identify y1 and y2 from yc. So auxiliary equation is d square minus 2d plus 2 is equal to 0. So roots of the auxiliary equation by using quadratic formula, or you can use calci also. D is equal to minus b plus minus under root b square minus 4ac divided by 2a. So d is equal to minus 2, that is plus 2, plus minus under root b square is 4 minus 4 times ac, that is 8 divided by 2 times 1. So it is equal to 2 plus minus under root minus 4 divided by 2. So it is 2 plus minus 2i divided by 2. So d is equal to 1 plus minus 2i. Okay. This d is equal to 1 plus minus I. Okay. So yc is equal to c1, sorry, e raised to imaginary real part into x. Real part is 1, so into x. c1 cos of x plus c2 sine of imaginary part into x, sine of x. So it is equal to yc is equal to e raised to x cos x, c1 times e raised to x cos x plus c2 times e raised to x sin x. So collect y1 y2 from yc. y1 is equal to e raised to x cos x and y2 is equal to e raised to x sin x. Now we need Wronskian to find out u and v by using MVP, method of variation of parameter. So Wronskian is equal to y1 is e raised to x cos x, y2 is e raised to x sin x, and take the derivative of corresponding functions. Derivative of e raised to x cos x is keep e raised to x as it is, derivative of cos x minus sin x, plus keep cos x as it is, derivative of e raised to x is e raised to x. Similarly, keep e raised to x as it is, derivative of sine, it is cos x, plus keep sin x as it is, derivative of e raised to x, e raised to x. So take the determinant, e raised to x into e raised to x. In the both the terms you have e raised to x, so e raised to x into e raised to x will be e raised to 2x. Cos x into cos x, cos square x, plus cos x into sin x. Okay, minus e raised to 2x, again product of those e raised to x you have, so e raised to 2x into bracket sin x into minus sin x minus sin square x plus sin x into cos x. Okay, take this e raised to 2x in common from both the terms, so you have cos square x plus cos x sin x minus minus will be plus sin square x minus plus will be minus sin x cos x. Okay, so cos x sin x can get cancelled. Wronskian is equal to e raised to 2x. Cos square x plus sin square x is 1. So simple Wronskian is equal to e raised to 2x. This is your Wronskian. So u is equal to integration minus y2 f of x divided by Wronskian dx. This is the formula. So u is equal to integration minus y2 is what? It is sin x. So sin x into f of x is e raised to x tan x. Okay, divided by Wronskian is equal to e raised to 2x dx. Okay, sorry, you have y2 is equal to e raised to x into sin x. Okay, so e raised to x will be e raised to 2x in the numerator. Already you have e raised to 2x in the denominator, so it will get cancelled, and integration minus sin x tan x will remain. Okay, dx. So now tan x is equal to sin x by cos x. So rewrite sin x by cos x. So u is equal to integration minus sin square x by cos x dx. So u is equal to integration, rewrite sin square x as, by using trigonometric identity, it can be written as 1 minus cos square x. So minus 1 minus cos square x by cos x dx. So u is equal to integration cos square x minus 1 divided by cos x dx. So u is equal to integration cos x by cos square x by cos x is 1 cos x. Okay, 1 cos x will get cancelled. Minus 1 by cos x is sec x dx. So u is equal to integration of cos x is sin x minus integration of sec x is, it is the formula we have, integration sec x is equal to log of sec x plus tan x. Okay. So u is equal to sin x minus log of sec x plus tan x. Okay. Now v is equal to integration y1 is e raised to x cos x multiplied by f of x is e raised to x tan x divided by e raised to 2x Wronskian dx. So v is equal to e raised to x into e raised to x is e raised to 2x divided by e raised to 2x will get cancelled. Cos x into tan x, it is sin x. Okay. So integration sin x is minus cos x. So yp is equal to u times sin x minus log of sec x plus tan x times e raised to x cos x plus minus cos x times e raised to x sin x. So this is equal to sin x e raised to x cos x minus e raised to x cos x log of sec x plus tan x minus e raised to x cos x sin x. So this function is same function with opposite signs, so this will get cancelled. Yp is equal to minus e raised to x cos x log of sec x plus tan x. This is your final answer. Okay. Now complete solution is y is equal to yc plus yp. Okay, so write this yc plus yp together. This will be your final answer. So this is Cauchy's differential equation. Cauchy's differential equation with variable coefficients. So here you have powers of x as coefficients of differentials. So in this case we have to use basic substitution. X is equal to e raised to z. Okay, so that is z is equal to log of x. Similarly, you have to rewrite that derivative terms x square d square y by dx square. It can be written as d into d minus 1 y. X dy by dx can be written as dy. Okay. So by using these substitutions, given dE is reduced to d into d minus 1 y. What is capital D here? Capital D is equivalent with d by dz. So now differential equation in y and x will be changed to differential equation in y and z. Okay. Now right hand side is x square. Here x is equal to e raised to z. So right hand side will be e raised to 2z. Take this y in common. So d square minus d minus 2d minus 4 y is equal to e raised to 2z. So it is d square minus 3d minus 4 y is equal to e raised to 2z. Okay, so auxiliary equation is d square minus 3d minus 4 is equal to 0. Hence roots are d is equal to, you can use calci or you can factorize this minus 4 such that addition of factors is minus 3. So addition of factors must be minus 4 and 1. Okay, so d is equal to 4 comma minus 1. In case of factors we have in case of roots we have to change the sign of the factors. Okay, here we are finding factors of minus 4, so we have to change signs of that factors, and it will be roots will be 4 and minus 1. Okay, so yc is equal to, now yc will be in terms of z as the differential equation is in z. So yc is equal to c1 e raised to 4z plus c2 e raised to minus z. Okay, but the original differential equation is in x, so you have to rewrite this solution in terms of x. E raised to z is x only, so you have to rewrite e raised to z as x, and you have raised to 4, so it is x raised to 4 plus c2 e raised to x raised to minus 1. Okay, similarly to find yp, 1 upon d square minus 3d minus 4 operating on e raised to 2z. In case of exponentials, we replace d by that coefficient in the power, so we have to replace d by 2. So 1 upon 2 square minus 3 into 2 minus 4 e raised to 2z. So yp is equal to 1 upon 4 minus 6 minus 2 minus 4 will be minus 6 e raised to 2z. Now again yp is in terms of z, but the original differential equation is in x, so we have to resubstitute for z. So e raised to z is x, so it is minus x square by 6. So in terms of x it is minus x square by 6. Now collect together yc and yp, that will be your complete solution. So y is equal to c1 x raised to 4 plus c2 x raised to minus 1 minus x raised to 2 by 6 is your required complete solution. Okay, so this is symmetric differential equation where denominators are complicated functions of x, y, z. So in such type of examples you have to use method of multipliers to solve this. Method of grouping is not easy in this case. Why? Because you don't have symmetric functions to cancel equal common parts in denominators, so we are going to use method of multipliers. So in this case, observe first two denominators. By observing, you will get, you have all 4-degree terms inside the brackets. Okay, and outside the brackets you have simple x, y, z. So if you have to convert, you have to find multipliers such that the addition is 0. So to have addition 0, you should have equal degree terms after multiplying by multipliers. Okay, that means everything you want is in x raised to is in powers of 4. So what will be your first set of multiplier? First set of multiplier is x raised to 3, x y raised to 3 and z raised to. So first set of multipliers is x cube plus x cube y cube z cube. So multiplying x cube to p, that is first denominator, you will have x raised to 4, 2y raised to 4 minus z raised to 4 plus y raised to 4, z raised to 4 minus 2x raised to 4 plus z raised to 4, x raised to 4 minus y raised to 4. So addition of all these things is equal to 2x raised to 4, y raised to 4. Already you have minus 2x raised to 4, y raised to 4 from the second term, okay, plus y raised to 4, z raised to 4 and minus y raised to 4, z raised to 4 plus z raised to 4, x raised to 4 and this minus x raised to 4, z raised to 4. So everything is cancelled and you have 0. Hence solution is given by integration x cube dx plus y cube dy plus z cube dz is equal to c1, that is x raised to 4 plus y raised to 4 plus z raised to 4 divided by 4 is equal to c1, which implies that x raised to 4 plus y raised to 4 plus z raised to 4 is equal to 4c1. This is your first solution. Second solution is, for second solution you have to consider second set of multipliers. Next set of multipliers is you can eliminate this x, y and z by multiplying by 1 by x, 1 by y and 2 by z. Why 2 by z? Because after multiplying by 1 by x you will get 2y raised to 4 and you have y raised to 4 term in this r, but the coefficient is minus 1 and here coefficient is 2. So the last multiplier will be 2 by z. Okay, so that you will have 2 here minus 2y raised to 4, z will get cancelled. Okay, so next set of multipliers is 1 by x. Now second set of multipliers is 1 by x, 1 by y, 2 by z. Okay, 1 by x into p plus 1 by y into q plus 2 by z into r is equal to x cancelled, y cancelled, z cancelled, 2y raised to 4 minus z raised to 4 plus z raised to 4 minus 2x raised to 4 plus 2x raised to 4 minus 2y raised to 4. So all the terms are having equally like terms, okay, with opposite signs. So 2y raised to 4 minus 2y raised to 4 0 minus z raised to 4 plus z raised to 4 0 and minus 2x raised to 4 plus 2x raised to 4 0. So you get 0. Okay, so second solution is integration of first multiplier dx plus second multiplier dy plus third multiplier dz is equal to log of c2. Why log of c2? Because you have all the terms after integration in terms of log. Okay, so log of x plus log of y plus 2 times log z is equal to log c2. Again, basic rules of logarithm we have to use. 2 times log z can be written as log of z square. Similarly, log of a plus log of b plus log of c can be written as log of abc. So similarly, we have left hand side as log of xyz square, okay, is equal to log of c2. Taking exponential on both sides, xyz square is equal to c2. This is your required answer.